So hello guys, today we are discussing about the inductive effect. So what is inductive effect? It is the permanent partial polarization created by shifting of electron pair in a single covalent bond towards more electronegative atoms. Means it is the partial polarization which is created by shifting of the electron via single covalent bond, that is sigma bond, towards the more electronegative atom. मतलब जहाँ पे ज़्यादा इलेक्ट्रोनेगेटिव एटम होगा वो उस तरफ खींचने लगेगा कार्बन की तरफ से. ओके, एंड दिस इज डिनोटेड बाय दिस symbol towards more electronegative atoms. So here like HCl, HBr, HCl in which hydrogen is delta positive and chlorine is delta negative because it is halogen which is always electronegative atom. So chlorine and bromine, so this is pointing towards the chlorine atom. The arrow means the inductive effect towards this chlorine atom, and here also towards the bromine atom. Now in this case of the carbon chain, in which we have taken the parent chain alkene, that is butane, in which chlorine is attached to first carbon. Here this forms delta, this is negative, this is chlorine is delta negative, and this carbon is formed delta positive 1. This is of the second carbon. This shows delta positive. This shows 2 plus, this shows 3 plus, and this is 4 plus delta positive charges, in which first of all this carbon is the chlorine is drawing towards this carbon by the first carbon, then second, and then third and fourth. But the inductive effect is mostly to up to the third carbon atom. Okay, now the types of inductive are plus I effect and minus I effect. In this positive inductive effect, this involves electron donating groups like CH3, like methyl, ethyl, propyl, butyl, all these groups which donates the electron. This is called as positive inductive effect. And in this case, negative inductive effect, in which halogens are mostly included, in which halogens have capacity which shows the electronegativity. So chlorine, bromine, iodine, fluorine, in which the fluorine is more electronegative than chlorine, than bromine, than iodine, as well as cyanide, nitro group, and tertiary amine also shows the negative inductive effect. In this case, hydrogen, the isotopes of hydrogen is also shows the plus I effect. Now this is the explanation about the plus I and minus I effect. Is that here the groups we have taken this carbon which is linked to 3 methyl group and the electronegative atom chlorine. So in this case, this CH3 giving the electron, this shows the plus I effect. Means these are electron donating group which is donating their electron towards this carbon. So यहाँ पे क्या हो जाएगा, ये CH3 दोनों भी कार्बन को this कार्बन को इलेक्ट्रॉन डोनेट कर रहे हैं, तो इस पे नेगेटिव हो जाएगा charges because there are too much electron which is giving by 3 methyl group on this carbon. So this shows the this shows the positive inductive effect, in which ये negative क्यों हुआ, because this 1 2 and this 3 chlorine NH3 groups are methyl group are giving electron, so there are electron density increases, so that this shows negative delta negative. But this due to this CH3 group giving electron density, so it shows the plus I effect. So carbon CH3 shows plus I effect. Now this, in this case, CH3 similarly this CH3 methyl group shows is withdrawing electron towards, means the groups attract or withdraw electron towards carbon atom. ये क्या कर रहे हैं कि यहाँ से द मिडल कार्बन के जो इलेक्ट्रॉन है उसको वो अट्रैक्ट कर रहे हैं और विड्रॉ कर रहे हैं टुवर्ड्स दिस CH3 ग्रुप, सो दैट अगर ये इसके इलेक्ट्रॉन इसके तरफ खींचेगा तो ये पॉजिटिव हो जाएगा, मतलब वो इलेक्ट्रॉन को लूज करेगा अपनी तरफ से. सो दिस शोज दिस कार्बन विल बी कार्बन पॉजिटिव. सो द CCl बॉन्ड शोज माइनस I इफेक्ट. इन दिस केस अगर ये कार्बन ज़्यादा पॉजिटिव हो जाएगा तो उसको खींचने की कैपेसिटी विद अदर इलेक्ट्रॉन विल बी इंक्रीजेस, सो दैट दिस CCl ग्रुप विल बॉन्ड शोज माइनस I इफेक्ट. सो द एग्जाम्पल ऑफ inductive effect are, question is which one is more acidic by order, which is acidic order बताना है negative inductive effect से. तो in this case we have taken this CH3 methyl ethene and this C triple bond C, in which here the acidity order in this case जैसे कि हमें पता है हाइड्रोजन इसमें लेस है तो इसमें S कैरेक्टर ज़्यादा है, इसमें S कैरेक्टर ज़्यादा है as compared to this and this. So more S character means the more acidic, and the acidity is directly proportional to the stability of the anion, so that the carbon will be more acidic than this ethyl group than methyl. The order will be CBA. Okay, by negative inductive effect. Because this will go first, ज़्यादा फास्ट अपना प्रोटॉन लूज करके वो नेगेटिव कार्बन को स्टेबलाइज करेगा. Now the second example is the isotopes of hydrogen. We have to find out the stability order. In this case, this is CH2 CH3, CH2 CD3. CD3 means the deuterium, and this is CT3 means the tritium. Okay, so in this these are the branching in which carbocation is also there. In this case, what happened here, the order of stability will be A first, then second, then this. Why? Because in inductive effect ब्रांच को ज़्यादा प्रायोरिटी दिया जाता है. कार्बन एटम के ब्रांचिंग को ज़्यादा प्रायोरिटी दिया जाता है, विच इज़ रिवर्स ऑफ हाइपरकॉन्जुगेशन, इन विच द हाइड्रोजन इज गिव्स मोर प्रायोरिटी. बट हियर इन दिस केस द CH3 group will be more prior. Okay, so the stability order of this group, in which first CH2 CH3 will be more more than CD3 deuterium and then tritium. This in case of this hydrogen isotopes. Now the next example, which more acidic, showing plus I effect. मतलब ज़्यादा पॉजिटिव इफेक्ट इन दोनों में से कौन सा है. In this case, here the carbon first, second, third, and fourth. This shows the inductive effect as like this, that this causes the carbon 4, that this form the 4 positive, this form partial 4 positive, this form 3 positive, and this is 2 positive, in which this CH3 will show inductive effect on this carbon, that is by +2 effect, and as well as this CH2 shows on this carbon inductive effect, that is giving inductive effect by +3 effect on this carbon atom. So the total number of electron are found to be, this is 2 + 3, that is 5 electrons are there, that is 5 positive. And in next example, here also this CH2 and this CH2, this CH3 will acquires how many positive, that is 1 2 3 positive, 1 2 3. Third position we show 3 positive on this CH group, and in as well as this this CH3 also shows the 3 positive effect, 3 positive. So in this case there are 3 + 3, that is 6 electrons or 6 positive, and there are 5 positive. So but here in this case plus I effect is directly proportional to the branching. Now the next step is what will be the order of stability of carbocation in inductive effect. So here the carbocation are given, similarly the isotopes of hydrogen atoms. In this case, what happened here, CD3 and CH3. So this first, that is A, this is B, and this is C. So A will be less than B, will be less than C. Why? Because these are isotopes of hydrogen. Here in this case the order will be A is less than B is less than C. Why? Because if the inductive पूछा है तो ट्रिटियम का ज़्यादा होगा as compared to hydrogen and deuterium, because hyperconjugation is maximum in hydrogen. हाइड्रोजन में मैक्सिमम होता है देन ड्यूटेरियम एंड देन ट्रिटियम, बट इट इज़ रिवर्स ऑफ इन इंडक्टिव इफेक्ट. सो ए विल बी लेस दैन बी विल बी देन सी, बिकॉज ट्रिटियम में ज़्यादा होगा इंडक्टिव इफेक्ट एज कम्पेयर टू ड्यूटेरियम एंड हाइड्रोजन एटम. सो आफ्टर दैट एसिडिटी ऑर्डर in this compound by -I effect. In this case, this is CH3, this is OH, this is CF3, this is OH. Means the OH are common, that is acid group is common in this. In this CH3 is replaced by CF3 and Cl3. But most acidic is, we know that fluorine is more acidic than chlorine, than the carbon, then the hydrogen atom. Why? Because the electronegative atom is more, fluorine is more electronegative than chlorine, and then carbon or hydrogen atom. So the order, the priority will be B will be greater than C will be greater than A. This is the -I effect. This shows the inductive effect, means the withdrawing of the electron from this fluorine is withdrawing electron towards from this carbon atom, so that this shows the -I effect. Thank you. If you like my video, please like and subscribe.